Okay, so we'll start the night by looking at scientific notation. Now, there's always a scientific notation comes up in the past papers. So I'll give you a sort of short introduction, look at one of the past papers questions. Okay, but please go and look at different questions for scientific notation and try and get your head round. Okay, it doesn't help with me trying to explain it again and again. It's one of those things you just need to sit down and eventually it will sort of click into place what I'm going through. Okay, so we'll spend the first wee bit on scientific notation. Okay, and then we'll look at fractions. So we'll look at mixed fractions. Okay, what is the mixed fraction telling us? Break that down into its individual components, look at the numerator, top line, look at the bottom line, and how we can figure out. Okay, and we'll go through some quite tough mixed fractions, so we can look at sort of techniques like multiplying things out, adding, subtracting, and that will sort of revise our fraction lessons from Unit 1 as well. Okay, off the back of that, we'll go into percentages. Okay, so again, always a percentage question, but I'll look at the relationship between what a fraction is and what a percentage is. Okay, that might seem obvious, but we'll look at, you know, the basic fractions and what they mean percentage-wise. Okay, break that down a wee bit, and then we'll go into some of the percentage questions that will come up. Okay, so something called appreciation, okay, and something called depreciation. Okay, don't you dare, internet is unstable. Okay, so we'll look at appreciation. Appreciation effectively is what you want to happen to your savings account. Okay, you want that to appreciate, you want that to go up. Okay, and that's going to go up by a certain percentage every year. So we look at that type of thing. Okay, we look at it increasing. Depreciation is the opposite of that. Depreciation is what happens to your car. So you buy a car, it depreciates in value, it goes down. So we'll look at those type of questions. Again, always one of those two come up in the exam, so good one to get our head round. It's quite a busy night. Okay, a lot going on. So okay, if we start to lose you about 8 o'clock, don't be too worried. Remember, this video will go up. Okay, so start to lose you about 8 o'clock, and what's happening here? Sorry, just trying to let someone in the room and it's confusing. Okay, so remember that video will be there, so don't worry too much if it gets late and we're pushing on a wee bit. Okay, so let's get on that. So scientific notation. So it's all about how we're writing down numbers, okay, and how we're communicating numbers and how we're reading numbers. Okay, scientific notation. Scientific notation. Okay, it's for when you're dealing
You're showing us on the screen.
Great shout. You'd think I'd be used to it by now, eh? Thank you, Sandra. Share screen. Scientific notations when you're dealing with very large numbers or very small. Now, just to double check, you didn't cover this right at the start, did you? Because I just had to double check that you sometimes done before indices, and I know that's when we swapped over. So that's why I just wanted to double check that we've not done scientific notation yet. Doesn't ring a bell? Cool. Okay, just making sure of that. Okay, scientific notations when we use very large numbers, huge numbers with lots and lots of zeros, or how we communicate very small numbers. Okay, so when we're talking about the size of an atom, okay, sometimes we need to communicate the size of that, so it's very, very small. There's going to be lots of zeros involved. Okay, when I'm talking about a large number, it's really anything over the number 10. Anything greater than the number 10 we can write down as scientific notation. Okay, small numbers has to be less than 1. Anything less than 1, we can actually write it down in scientific notation. Okay, because we want to express, okay, we want to write down the large number or the small number starting with a number between 1 and 9. Okay, so we want to express the large or small number using a number between 1 and 9. Okay. Now that will make a wee bit more sense when we start looking at it. Okay, so as I said, it's really anything over the number 10 we can express as scientific notation. Okay, so if we look at an example spelled incorrectly, okay, if we look at the number 240, okay, we can say that can also be written as 2.4 multiplied by 100. Okay, effectively we've moved the decimal point, and now we're expressing that 240, okay, as a number between 1 and 9. So we're expressing it as 2.4, okay, a number between 1 and 9. But we've got this 100. Now we know that 100, okay, can also be written as 10 squared, okay, 10 to the power of 2. Okay, so we can write 240 to 2.4 times 10 to the squared. Okay, now obviously we don't want to write this part out every time. Okay, but we want to express a larger number in this sort of format, followed by something like that. Okay, so we want to express the first part of the number by something between 1 and 9. Okay, and then the second part will be times 10 to the power of. Okay, what that to the power of is telling us is how far we need to move that decimal point, okay, to then write that out as a complete number again. Okay, so let's put a wee bit bigger number. So we say 135,000. Okay, I'm going to say I can write that as 1.35. Okay, so I've moved the decimal in here to get me a number between 1 and 9. Okay, so 1.35 greater than 1, less than 9. Okay, 1.35, that's going to be times 10. Now I'm going to count how many times I've had to move that decimal point, okay, to get to that 1.35. Okay, so 1, 2, 3, 4, 5. Okay, so currently the decimal point lives here. Okay, right at the end of that number. Okay, so when we're writing out a whole number, okay, that whole number could essentially be written as 0.00. Okay, there's nothing after that decimal, so we don't show it. Okay, but there is a decimal at the end of that. So we've moved that decimal 5 places. So that's 1.35 times 10 to the 5. Okay. Let's go even bigger. Okay, that's a hell of a big number. Okay, let's say that is the distance to our next galaxy. Okay, or the amount of stars we've got in the universe. Okay, something ridiculous to that, or the amount of grains of sand on the beach. Okay, really big number. Now, obviously, if we were writing out an equation, we don't want to use that number. Okay, that would just be daft. Okay, but sometimes we do need to use these size of numbers. So we want to write that starting with a number between 1 and 9, so 4.5 times 10. Okay, and that, you're going to be moving the decimal point from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so 14. So we've moved that decimal point 14 places. Okay. Very importantly, you've got a button that does this in the calculator. Okay. Now for me, it's down the bottom beside the answer button. So down the bottom row of my calculator, I've got 0, a decimal point, and then this button that's times 10 to the x. Okay, and it's that button times 10 to the x. Okay, it's actually the button that you use for pi. So remember, if you shift and pi something, okay, that button's there. So it's times 10 to the x. Okay.
Sorry, what is it we're looking for, Daniel?
So a button, where's my camera? Button that shows
X10
yeah,
to the power, yeah.
x. So x 10 to the power of x. So effectively that's times 10 to the power of x.
I haven't got that on mine.
Yeah. Let's see yours. Stick up to the camera.
You can't see it, can you?
Nah, can't see anything.
Mm,
Should be somewhere. What make of?
Casio FX 83WA.
83. Let's see what my other one is. No, my other Casio's in the same place as well.
What's the button called again? And then I'll do the research after. X to the
Have you
Y.
got an EXP button?
Yeah, I
that's it.
just use that. Okay.
That's it.
Thank you.
EXP. So if you've got times 10 to the power of x down the bottom, or if you've got a button that says EXP, let me just check that. 1.5. Yeah. Okay. Let's try those numbers that we've just done. Okay, so if I put 2.4 into my calculator, then press that button. Okay. If you've got EXP, it should give you a wee E. Just check it out. Okay. If you've got a times 10 to something, it should give you a wee times 10 beside that 2.4. And then we did the power of 2. Okay, so you just type in the number 2. Okay, so I'm getting that. Okay, so I've got 2.4, either e to the 2 or 2.4 times 10 to the 2. Okay, and it should give you 240. Okay, so if you try those with other numbers, 1.35, that button times 10 to the 5, it should give you 135,000. Okay, and if you do 4.5 times 10 to 14, it doesn't give you it because your calculator's not big enough. And that's why we need that button. The calculator's not big enough. Okay, let me see if that's the case in this one. Yeah. Okay, so the screen in the calculator is sometimes not big enough for the number, so that's why we need that. Anyone having issues with that with a calculator? Okay, if you do, fire me a wee note and we can look at it. Okay, some calculators are different. Okay, but it's that EXP button you're looking for, or times 10 to the power of. Okay, so that's very, very big numbers. Okay, so times 10 to a positive number And that's the number, that's the decimal point that we can move and we can count forward from. Okay. Now, we can also use this for very small numbers. Okay. So using this for small numbers. Okay. We've got a number below 1. Okay, so let's say 0.45. Okay. We want to express that with a number between 1 and 9. Okay. So we'll express that as 4.5. We're going to write it as times 10 to, okay, and then we're going to put a power there again, okay, and we're going to use a negative power because the decimal is going the other way this time. Okay, so 4.5 times 10 to the negative 2 means I've moved that decimal 2 positions like that. Okay. Now, why is it negative? If you think about what a negative power means, okay, it means that it would be a positive power if it was in the bottom of a fraction. Okay, so what I am actually saying there is we are 4.5, okay, times 1 over 10 squared. Okay, now you don't need to know that, that's just reasoning behind it. Okay, so if we did 4.5 over 100, we would go back to that. Okay, so now you don't need to know that. You do need to know that if it's a negative power, it goes in the bottom of a fraction. Okay, but you don't need to go from this to this. Okay, that's just reasoning for you.
Yeah,
Okay,
but it does help us understand
yeah,
the 10 to
and
the
that's
minus 2, what it means.
Yeah, so that negative just means we're dividing by 10 to the power of. Okay, but we write it on the top line like that. Okay, so we write it in that format. Okay, so something else, so if we had 0.000104, okay, we were to write that number. Okay, we're moving that decimal point 1, 2, 3, 4 positions times 10 to the negative 4. Okay. And just for argument's sake, okay, we had a really small number. Okay, that can be written as 2.4 times 10 to the negative, and we're moving this 1, 2, 3, 4, 5, 6, 7, 8 to the negative 8. Okay. So again, in your calculator, guys, if you want to write that out, okay, so write out 4.5, the button, either exp or times 10 to the power of button, okay, and then you're putting negative 2. Okay, now what it might give you is a solution in fraction form. Okay, so you should have a wee button that allows you to convert or transfer, whatever it may be, okay, from fraction form into decimal form. Okay, and it's for me, that's an SD button. Okay, here, that wee SD button. Okay, and that allows me to go from decimal to fraction. Now I'm looking on my other calculator. If you don't have that, when we're in person, I'll have a wee look and just figure it out in your calculator. Okay. So try all those numbers just in your calculator, just try to make sure you can get them. Okay, so we put 1.04 times 10 to negative 4. Okay, in decimal format, well, it's actually too small. Okay, it doesn't actually fit in the calculator. Okay, so either or the other one. If it doesn't fit in the screen of the calculator, it won't actually give you, it will just give you the exactly same thing you've typed in. Okay, 2.4 times 10 to the... Anyone having issues with that in their calculator? Saying the power for me is -7. You've not got enough decimals. You've not got enough zeros. 0. Are you getting 0.24 times 10 to the 7? -7. Okay. So if you type that into your, yeah. Okay, so what they've done, stupidly, okay, if you've got 0.24, okay, it is correct, but they've moved the decimal one place further. Okay, so it's not a particularly nice way to write it. It isn't mathematically incorrect. Okay, so what Faye's saying, where I'm telling you to write it in between a number 1 to 9, okay, what Faye has seen okay, for whatever reason her calculator's given her times 10 to the -7. Okay, I might have cut out a wee bit there. Okay, so that's what her calculator's given her. Okay, that is correct. It's moved the decimal point 3, 4, 5, 6, 7 places. Okay, so it's the same number. It's just a quite a poorly written way. Okay, but it's not incorrect. Your calculator should still be able to go from, if you type in 2.4 times 10 to the -8, it will still give you that same number. Okay, so you can write it out in other forms, it's just not very tidy, if that makes sense. Okay, so try and stay consistent and keep it between a number and 1 and 9. Okay, so for us 2.4 times 10 to the -8. Okay, 0.24 times 10 to the -7 is the exact same answer, it's just 1 decimal point. Okay, I hope that helps. Okay. What some people like to do it times 10 to the -9. Okay, do it in groups of 3, so you might see that, things like that written out. Okay, again, oh sorry, that's a lie. Again, if your calculator's showing you that's still correct, again, the decimal point's just been moved one further bit back. Okay, so if you're seeing that, the decimal point's just gone another step. Okay, so that decimal point can move, and some calculators might throw that about. Okay, stay consistent. Okay, in the exams, you'll see it between the numbers 1 and 9. Okay, well, that explains that. Okay, so already sort of alluded to it, you can go the opposite way as well. So you can do that process in reverse. So if we get given the number 2.4 times 10 to the 4, power of 4, okay, that will be 24,000. Okay, so you can go the opposite way. Now, in the exam, it will normally ask you to leave it in scientific notation. Okay, in the off chance the number looks better not in scientific notation, okay, it might ask you to do that the other way. Okay, very, very rare, but you can do it. Okay, so the reverse 2.4, so the decimal started here, 1, 2, 3, 4. Okay, it's made 4 jumps to give us 24,000. Okay, so that's that written out. We don't put it in, but essentially there's a decimal point there. Okay, but we don't write it out. Okay, so it's 24,000. Okay, another example of that. If we had 3.15 times 10 to the 6. Okay. We're moving from the decimal point, we're going 6. Okay, so decimal point starts here. 1, 2, 3, 4, 5, 6. Okay, everywhere there's a space and a 0. Okay. The trickiest one is to go the opposite way when it's a negative. Okay, and reverse when it's a negative. Okay. So you get that and you have to write that out fully. Okay, that's sometimes one that sort of stumbles. Okay. Simple reason is we need to start at the decimal point and then put in the zeros until we get to the number. Okay, so we're going to start with a decimal point. Okay, in front of the decimal point there always has to be something, so we always have to put 0. Okay, so 0 point. Okay, so we'd never start with a decimal, we'd always have a 0. Okay, and then after that 0, because it's -6, we're going to have 5 zeros and 4 and 0, 3, 4. Okay, so the decimal point is 1, 2, 3, 4, 5, 6 places away from when it started. Going in the negative direction is the toughest. Okay, I'll still, if I see that written out in an equation, I'll still have to sit down and go, right, have I got this right before I move on? Okay, so it still does catch you a wee bit. So, should allow you put some of them in your calculator.
The zeros. You counting from the left to the right?
You can go either way.
Oh, right, okay.
Yeah, so it's essentially you're just looking for where the decimal point starts and where it will finish.
Right, okay.
So you're, for a negative, you're having to fill in the zeros on the left hand side. For a positive power, you're filling in the zeros on the right hand side of the number. Okay. So it is quite tricky when you see it written out like that. Okay. It's one of those ones that just needs a couple of practices. Okay, so sitting down for an hour or so, just making sure you're sort of comfortable going through them. Okay, chat there. Does the last so if it's coming up, sorry Faye, so if it's coming up a fraction, Abby, there's a wee button, and for me it's just above the delete button. Okay, and it's an S with an arrow pointing to a D. Okay, so that changes it to decimal. So if you press that button, it should change the fraction into a decimal. Okay, so give that a go. should allow you to do it. Faye, does the last zero between the numbers? What would that? That one, Faye, or that one? In fact, I'll do that different colour. Blue zero or green zero? Right one. All right. Okay. So no. So what that is, so there has to be something before the decimal point. Okay. Now there's no whole numbers before the decimal point, so we can't start a number by putting a decimal and then writing like that. Okay. It just doesn't look right, and it's confusing in a mathematical sense. Okay, you would easily make mistakes if we put it in that format. Okay, so we'd have to put a zero there just so we have something there. Okay. Right, so what's happening there, Abby, is there's not enough. So if you've got 2.4 times 10 to the 4, oh, I should give that. We'll come back to that, Faye. Okay, so back to the 2.4, that comes up. That just means there's not enough room in the screen for the amount of zeros. Okay, I think is what's happening, or your calculator just doesn't want to give you those zeros written out. Okay, which is frustrating, but essentially that's what it's doing. So your calculator's putting it that format because it knows it's mathematically correct. It's just frustrating because we can't see it. Okay, so yeah, it's just your calculator being annoying, unfortunately. I'll have a look, Abby, when we're in, if you're in one of the times, and then we can have a look at the calculator and just make sure we're comfortable with it. So to answer Faye's question, do you stop counting the decimal when there's a number before a zero? Perfect, thank you. Sorry, yeah, I'm trying. Wrong chart. No. Do you stop counting the decimals? Do you mean if there wasn't? So you stop counting the decimals when there's a number before a zero. So a number before this zero. So here. Okay, so if that was the case, you wouldn't be doing this process. So if that was, say, the number 40.104, okay. What could you do there? I'm trying to think of putting this in an example that would make sense, because essentially yes and no. Okay, so we could do this sort of process again, where you can move the decimals as many places as you want. Okay, what we're trying to be consistent with is that number in front of the decimals between 1 and 9. Okay, so I'd want that number in front of the decimal to be before 1 and 9. Okay, why that's not the case in very small numbers? Okay, very small numbers have to be less than 1. Okay, so very small numbers like 4.034 times 10 to the negative 6 has to start with 0 because it's less than 1. Okay, so for that instant, for this to happen, there would never be a number in front of that 0. Okay, so for a small number to happen, we need to start with a 0 because mathematically that's just the way we write it out. Okay, we can never start something just with a decimal point and then we count from there. So we start counting from that decimal point. So that 0 to the left of that decimal is just sitting there. Okay, that's just to tell us that it's a number below 0. Okay, so from that decimal point, and then we start counting right for the smaller. From the decimal point, we start counting left for the bigger. Okay. Oh, right, okay. Got you. Okay, let's tidy this up a wee bit. 4. I'll just write this out again so I can. Okay, so exact same. So I'm saying 1, 2, 3, 4, 5, 6, because that's negative 6, and the decimal place is stopping after the 4. Okay, so because that decimal point is in the number that we're starting with, it's after the 4, that tells me when to stop putting in zeros. If that makes sense. Okay, so similar to that sort of previous example we had. Okay, it's the exact same number because that decimal's there, and that's negative 7. 1, 2, 3, 4, 5, 6, 7. Okay, but I want to be consistent. I want to try and not confuse matters and try and keep that number in front of the decimal below 9. Okay, in between 1 and 9. But that bottom one, that is the exact same number. Okay, but we stop counting after 0 because that's where the decimal is. Okay, or we could write it out as 403. Again, it's the exact same number. Okay, we've just moved that decimal point one more. Okay, so in this case, we'd stop counting after the 3. 1, 2, 3, 4, 5, 6. Okay. Okay. So whatever this decimal is where you stop counting. Okay, so that doesn't matter what number that is. Does that make sense? Okay, I hope that makes sense. Yeah. Okay, so want to have a wee practice using your calculator. Okay, make sure we're sort of getting the right answers. Okay. So if we try put in our calculators 2.2 times 10 to the 3 multiplied by 4.7 times 10 to the 5. Okay, so we're typing in and we're using that button, remember? Okay, so we're using that button down the bottom. Okay, either your EXP button or your times 10 to the power of button. Okay, if you try and put that in your calculator, times 10 squared. That's cute. We actually get the right answer. Okay, so using that button, try and put that in 2.2 times 10 to the 3 multiplied, and that's just the normal multiplication button, 4.7 times 10 to the 5. Okay, we should be getting quite a big number. Some people will be getting this in scientific notation. Okay. Okay, so some people will get it in the calculator shown as that. Some people will get it in the calculator shown as that. Okay. In the exam, you need to be very careful if it asks for scientific notation. Even though your calculator gives it like that, and you can write that line out, that's not a problem. You then have to convert it to that format. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay, that number that I've circled in red, let's stay consistent. Let's call that in between number 1 and 9. Okay, now I've shown you it doesn't have to be like that, but staying consistent so we don't confuse ourselves. Let's just keep that number in front of the decimal between 1 and 9. Okay, when it's in scientific notation. Did anyone not get that or is way off that? Sorry if I'm cutting in and out. Okay, we're comfortable with that. Second one I want you to put in your calculators. 3.4. Okay, if we try and put that in our calculators, we should get a big number. Okay, we should be getting 1.904 times 10 to the negative 8. Okay, or okay, if your calculator's showing that, it'll be the same thing. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that decimal's gone 8 places. Okay, that decimal's moved 8 places to the negative. Okay, it's gone that other way. Okay. One other thing I want you to try in your calculators is just divide it. Okay, so exact same process, there's nothing different. 1.95 times 10 to the 4 divided by 2.32 times 10 to the 5. Okay, so big numbers. Okay, 1.95. Okay. If that gives you in a decimal, try and change it using that SD button. Okay, it should give you the answer 0.84, oh sorry, 0.084 continues on. Okay, it might also give you it as 8.4 times 10 to the negative 2. Okay, so that and that's the same. Okay, we've just moved that decimal. Okay, 2 places to the right. Okay.
Sorry, Daniel, if you've got that number 0.084,
Mm-hmm.
move it that negative 2 places.
How did I get from this one to this one?
No, how, if you get your answer on the calculator, the
Yep.
one above. Yeah, if you get that in the calculator, how do you know to move that 2 places?
You don't have to, it's just in case the calculator gives it.
Right.
Okay, so the calculator might give you it in that format. Okay, so if you've been putting it in that format, some calculators will automatically go to it. Okay. Or
Oh, so just move the decimal point anyway.
yeah,
Okay.
but it's worthwhile being comfortable knowing which is that's the same. Okay, so effectively all that number is down the bottom is we've moved that decimal point 2 places to the right. Okay, and we've turned what's quite an awkward small number into something that's a lot more usable in big equations. Okay, and that's why you do it. It's just another way of writing it out that looks a wee bit neater. Okay, especially when it's got lots and lots of zeros in it. It's just a wee bit neater way of writing that out. It means we're not going to make mistakes when we start putting it into bigger equations. Okay. Now, thankfully, we don't need to put that in the bigger equations. But okay, so how does that look when we get given it in an exam? Okay, how does that look when we get given it in an exam? So let's see if we've got in. Yeah, okay. So in your booklets, scientific notation is in the first booklet, okay, booklet 1. Okay, so you might not have it open on top. Okay, page 18. Okay, so 18, 17, and 16. Okay, so the first booklet, 16 to 19. Okay, most common way you'll see this question is written out in a wee story. Okay, I don't know if you can see that very well. So written out things like this. Okay, so the distance between Earth and Mars is an average 1.65 times 10 to the 8. Okay, because obviously that's going to be a really big distance. Okay, it's really far away. Okay, spaceships designed to travel between Earth and Mars at an average speed of 20,000 miles an hour. Okay, how many days does the spaceship take to reach Mars? Okay, so there's a lot going on in that question. Okay, essentially it wants you to divide that, the amount of miles, by 20,000 to find the amount of hours, and then turn that hours into days. Okay, so 1.65 times 10 to the 8 divided by 20,000 will give you the amount of hours, and then how many days. Okay, so it's looking for how many chunks of 24 that will be. Okay, so how will we go with that? Remember the answers at the back. Okay, so how will we look? Let's have a wee look at this one. Uranium is a radioactive isotope with a half-life. Okay, this means that only half the original mass will be radioactive after that amount of time. How long will it take for the radioactivity of a piece of uranium to reduce to 1/8 of its original level? Give your answer in scientific notation. Okay, so in the exam it will tell you give your answer to scientific notation, or give your answer to the nearest day. Okay, things like that. So that's the way you're going to see them. Okay, I'm going to do an example. Again, it's a past paper question, so leave these exam questions up to yourself. Okay, just due to time tonight. Okay, if you've got any questions, we can certainly go over them in class, so don't sit in a question. Please, at this point, do not sit in a question. Okay, I'm going to give an example that's not there, okay, that's not in your booklet. This is from past paper 2016. Okay, and this is in the calculator for obvious reasons. Okay, try to do that in your head would be tasty. Okay, so question asks, pollen sample weighs 12 grams. Okay, so a collection of pollen weighs 12 grams and contains 1.5 times 10 to the 9 pollen grains. So that's how many pollen grains are in that sample. All right. Calculate the weight of one pollen grain in grams. Okay, so one part of this is trying to figure out what this is asking you to do. Okay, so we've got a sample of pollen, so we've got a collection of pollen, so a spoonful of pollen, okay, and that weighs 12 grams. That contains 1.5 times 10 to the 9 particles of pollen. Okay, so 1.5 times 10 to the 9, if we were writing that out fully, one, two, three, 4, 5, 6, 7, 8, 9. Okay, so that's 1.5 times 10 to the 9 written out fully. Okay, now you don't have to do that in the exam, I'm just showing you. Okay, so 12 grams of pollen contains that many particles of pollen. Okay, so there's that many. So I'll show you a link for 2 seconds and we'll look at where you can find more past papers. Okay, I've put in previous emails, but I'll show you the link. Okay, so 12 grams pollen contains 1.5 billion particles. Okay, is that a billion? Yeah, 500 million. That's a billion. Okay. Funny that Jeff Bezos has more money than that. Okay, there you go. But let's not get political. Okay, so what's it asking you? One pollen grain in grams. Okay, so what you need to do, okay, is divide 12 divided by 1.5 times 10 to the 9. Putting that in your calculator. 12 divided by 1.5, your wee button, to the 9. Okay.
See, instead of writing it out like that, can you just do the big number divided by 12? Would that work?
You don't need to write that.
So you
And
can
then-
just do the wee short
Yeah,
way.
you don't need to
Okay.
write that in an exam. I'm just showing you straight out. Okay. In an exam, this is where you would start.
Okay, look.
Okay, so 1 pollen grain equals 12 divided by 1.5 times 10 to the 9. Okay, and you'd write that out just so the marker could see you're thinking that step. Okay, so 1.5 times 10, so 12 divided by 1.5 times 10 to the 9 is giving me 8 times 10 to the negative 9. Okay, now it might give you in a different format, so it might give you times 10 to the negative 6 and write it a slightly different way, or times 10 to the negative 12, again write it in a different way. That's just where they've put that decimal point. That is your answer. That is all that question is. Okay, it'll be a nice wee 2 marker. Okay, just to show you're picking up the right information from it. Okay, but they do enjoy a story with scientific notation in it. Now, what I would say is often you'd get an answer and try and see if it makes sense. Okay, so we know what pollen is. Okay, we know it's tiny, so it's not going to weigh much at all. Okay, so that 8 times 10 to the negative 9 is that. Does that make sense? Yeah, sort of. Pollen's tiny, it doesn't weigh much. Okay, we sort of know what a gram is. You know, it's not particularly big, but you know it's heavier than a grain of pollen. Okay. But again, you don't need to go from that step to that step, okay? Knowing that's your answer. Okay, that's all that question is. Okay. Because it's a small number, so you're dividing a number by a really big number, and it's becoming a really small number. Okay. So we're dividing 12 by 1.5 billion. So how many 1.5 billions go into 12? 0.00008. Okay. Right. So let's have a wee pause there. That's about as far as I want to take it. Again, go back into the booklet, your pack 1. Okay. Remember the answers are at the back. There's some sort of nicer questions earlier on, okay, that just ask you to practice your calculator and things like that. Okay, ask you to write it out. Check you've got the full understanding of it. Okay, so like -7. I wouldn't write that number out, my word. 6.6 times 10 to 21. Mamma mia. Alright, so try and rewrite those sentences, or try and rewrite those numbers with the full number, okay? Don't do F, that's just ridiculous, okay? Couple of things to practice in the calculator. That's starting to put them into questions. What happened there? That's starting to put it into questions.
So that one says standard form at the top, so is that the same as standard notation?
Yes. Good
Okay.
question. Yep, exactly. Okay, so answer each of the following standard form. So yeah, without standard notation. So 1.85 times 10 to the 5 miles per second. Okay, so light's pretty quick, we know that. Okay, 1.85 times 10 to the miles per second. How far will it travel in an hour? Okay, so that couple of things is part of that. It's a reasonable question for a test. Okay, so how many seconds are in an hour? We need to know that. Okay, so 60 seconds in a minute. There's 60 minutes in an hour. So there's 3,600 seconds in an hour. Okay, so deduce from that. Okay, so it takes a wee bit of working out, but it's quite good to practice. Okay, that sort of thing. These are the same, similar type things, okay, but just with negative. Okay, again, it puts it in question form and story form, so it's a good wee practice. Okay. And then these are sort of exam type questions. So these are sort of exam level. Okay, so have a wee go at that and try and make sense of it, digest it a wee bit. Okay, on your own time. Scientific notation, when you get a hang of it, it's quite nice. It's not a problem at all. Okay, so it's not out there to trick you. It is literally just putting it in a neater form. Okay, so okay, nice one, guys. Sorry. Okay, superb. My unstable internet, lovely. Okay, so next part of this evening, what you want to, okay, is again looking a wee bit more about how you write numbers out, how we communicate numbers, and what it means when we display numbers in a certain way. And we want to look at fractions this time. Okay, so going to start by looking at mixed numbers. Okay, and that'll make sense when I give you a couple of examples. Okay, mixed numbers to start off with, mixed fractions. Okay, and then we'll look at how we go from a fraction to a percentage, and then we'll work through our percentages. Okay, so mixed fraction itself is a question in the exam, and then percentages is part of appreciation, depreciation is a question in the exam as well. Okay, so a couple of questions linked to this. Perfect. Okay, so have I shared? Right, this one. Okay, so fractions. Okay, we're going to look at something called mixed numbers. I cannot write. Okay, and what do I mean by mixed numbers? It's when they're displayed in format, we've got a large number, which is the whole number, followed by a fraction. Okay. Very importantly, they have to be right beside each other. Okay, so there's no symbol in between. It's a big whole number, okay, followed by very closely a fraction. And that's really obvious in the exams, okay, in the questions, when the questions come up, when that's written out. Okay, so we'll look at a couple later on, but they are really obvious when they're written out. Okay, so formats like that, 2 and 2, 4 and 2/5, 2 and 1/3. Okay. Okay, let's think about what that's shown us. Okay, so that's maybe a 1 down the bottom, by the way. Okay. Sorry, a 9. It's maybe 8/9. Okay. Now, why are they written like that? What is that trying to show us? Okay, so we know a whole number can be displayed. Okay. If we say we have number 1, sorry, we have a fraction, okay, say 5 over 5. The numerator and the denominator are the same. We can write that as the number 1. Okay, it's just 5 divided by 5. How many 5s go into the number 5? 1. Okay, so a whole number can be written as the number divided by the same number, if that makes sense. Okay, so whole numbers can be written like that. Now, how can we use that in this respect? What's that telling us? What something like this is telling us, okay, 4 2/5, okay, this is 4 wholes plus 2 more fifths. Okay, so how can we solve that? Well, we create something called a top heavy fraction. A top heavy fraction is when the number on top is bigger than the number on the bottom. So the numerator, the top number, is higher than the bottom number, the denominator. Okay, and how we convert one to another, okay, is multiply the bottom number by the big number. Okay, so your top line would be made up of 4 multiplied by 5 plus those 2/5. So there's 4 whole numbers, okay, plus remainder of 2, okay, which equals 20 plus 2 over 5, which equals 22 over 5. Okay, so 4 2/5 we can convert into a top heavy fraction of 22 over 5. Okay, now if we've got 2 1/3, we can do the exact same. 2 1/3 means we've got 2 whole thirds. Okay, so we've got 2 times 3 plus that 1 extra third divided by 3. So we've got 6 plus 1 over 3, 7 over 3. Again, top heavy fraction because the higher number's on the top. Okay. 3 4/7. 3 times 7 plus 4 over 7. So that's 21 plus 4, which is 25 over 7. Then that last one, okay, 1 8/9. So 1 multiplied by 9 plus there's 8, 17 over 9. Okay. When are these useful, or when do you have to do these? Okay. So when we've got one of these mixed numbers or 2 of these mixed numbers, and we're looking to add or subtract or multiply or divide, okay, when we are adding or subtracting fractions, okay, we're doing the kiss-smile method. Okay, and we're cross-multiplying, we're multiplying the bottom as well. Okay, importantly, that's one of two common methods taught. So you might, if you're doing this again, okay, and you did NAT 5 maybe 1 or 2 or 3 years ago, there is another way of teaching that, adding, subtracting. Okay, I've focused on KISS Smile. Okay, that in this way, and we'll see later on, might overcomplicate things. Okay, because the numbers get a bit big. Okay, but this is why I wanted to do this, just to show some tricks of when we're multiplying out bigger numbers. Okay, just to make sure we're comfortable with that. So we're following that KISS Smile. So the top multiplies with the bottom, top multiplies with the bottom, and then we multiply the two denominators together. Okay, just to pull those fractions together. Multiplying fractions, nice. Okay, just means top times top, bottom times bottom. Okay, so nothing complicated to multiply, straightforward. Top multiplied by top, bottom multiplied by bottom. And we're dividing fractions. Okay, remember the rule, we flip the second term. So flip the second fraction, then multiply as normal. Okay, so there's one extra step in there. Again, as long as we remember to flip that, okay, and then change the sign in the middle, it's a pretty straightforward, straight off multiplication. Okay, so again, these rules, when we apply them, we can't apply them when we've got something in this format. We've got a mixed number like that. So that's why it's important that we can change these mixed numbers into top heavy fractions. Okay, fractions where the top is going to be larger than the bottom. Okay. Thing for this, okay, we need to be really good at simplifying fractions down. Now we've done that quite a few times over different units, different examples, okay? But it's just a case of really making sure that you can see how we can simplify a fraction down, okay? It's not always simple to do, okay? So, example 1. Okay. The question in the exam will always state, express as a single fraction. In its simplest form. Okay. That's a wee reminder just to make sure that you are simplifying it down, each part. Okay. So let's see the type of thing we could get. Okay. So we could get 7 5/6 minus 3 1/3. Okay. First step that we need to take, okay, is creating top heavy fractions with that. Now that's a fraction negative, or fraction subtraction fraction, or subtract. That's more difficult to say than it should be. Okay, we're taking away a fraction from another fraction. Okay, so we need to do the KISS Smile, but we can't do the KISS Smile because we've got mixed numbers. So we need to make them top heavy fractions. Okay, so we're taking the big number and we're multiplying it with the number in the bottom. Okay, so 7 times 6 plus 5. Okay, that 5 is just this number. Okay, that's where we're getting that number. Okay, so 7 coming from there, 6 is coming from the denominator. Oh. Okay, so there's 7 wholes, So 7 times 6 is 42 plus 5. So you're 47 over 6 minus 9 plus 1, which is 10 over 3. Okay. And this is where the process of KISS-SMILE sometimes leads to quite complicated results. Okay. So KISS-SMILE, what we do, 47 times 3, 6 times 10, and then the denominator we're multiplying together to get the new denominator. Okay, so we need to be good at sort of big multiplications. Okay, now at this point when you're in an exam, don't be scared to take this to one side and do it to one side. Okay, so we need to do 47 times 3. Okay, so in school, you'll probably be taught the column method. Okay, taught that method. We do 3 times 7, which is 21. Okay, that 2 carries forward. 3 times 4 is 12. Is it? Yep. 12 plus that 2 on. Okay, so we're getting 141. Okay. So we get 141 minus, and it's 6 multiplied by 10, 60. And then the multiplication down the bottom is just 6 multiplied by 3 is 18. Okay. This could come up no problem at all in the non-calculator. Yes. So give me 2 seconds, Faye. I'll go through that just to show them what you mean. Okay, but the way we've done fractions to this date has been that the KISS-SMILE method. Okay, so I'll show you what Faye means in 2 minutes. Okay. Yes, so 141 minus 60 over 18. Okay, so that'll be 81 over 18, which is quite big in itself. Okay. Then we can take it to 9 over 2. Okay, so there's 9 nines in 81. Okay, and there's 2 nines in 18. Okay, so that's simplification. Okay, so tidy that up a wee bit. So there's one more thing that we need to do once we reach this point. Okay, and that's put it into or back into a mixed number. Okay, so we need to put that okay, so what we need to do, now we've simplified it as far as we can, can't simplify that any further, okay? We need to know how many 2's go into 9, and then we need to know how many remainders we've got. Okay, so we need to go through our 2 times table until we get past 9, and then work backwards from that point to work out how many remainders. Okay, so 2 times table, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 8, 5 is 10. Okay, so we've got 9 over 2. So we're looking for where 9 fits in here. So obviously it fits in here. Okay, so we have 4 whole 2's. Okay, plus 1 remainder. Okay, which will be our 1 over. So our answer is 4 wholes plus a half. Okay, so we've reversed that process. So we've looked at how many 2's are in that. Okay, we've removed the holes. Okay, and then we've put that back into a fraction. Okay, let's go back to the comments. Okay, so what I think you mean, Faye, is there's another technique that we can use. Okay, I like the kiss smile technique. Okay, it's a nice one to follow and it's not bad. Okay, what Faye or what someone's asked is there an easier technique instead of multiplying 47 times 3, which I'll admit is not a particularly nice multiplication to do. Okay, but again, being familiar with that and knowing how to do it, it's not the worst thing in the world. Okay, so I'm going to write this out again and I'll go through another process that we could go through. Okay, so go to one side. 756 minus 3 1/3. Okay, and I'll give you the option of doing this. Okay, so same process to make top heavy fractions, so that's still going to be our first point. Okay, so 7 times 6 plus 5. So this step's the same. 3 times 3 plus 1. 3. What was that? 42, 47. Minus 9, 10. 3. Okay, so we've got a denominator 6. We've got a denominator 3. Okay, we know 6, or sorry, we know we can get 6 by multiplying 3 by the number 2. Okay, we can double that. So if we double this on its own, okay, if we multiply just that by 2, we can get the expression, and then that's a hell of a lot easier. Okay, because the denominator's the same, we can bring them together and simplify that down. Okay, so let's just go back to this position. What we've done there is just take that 3. To get to the number 6, we just need to multiply that by 2. Okay, you need to multiply the top and the bottom if you're doing that. So you're doubling that fraction, okay, to get 20 over 6. Okay, so essentially what we're doing is doing the same process that we use when we're simplifying it, but we're almost making it like going back up. We're doing it in reverse. Okay, so 20 over 6 is the exact same as 10 over 3, but it allows us to have the same denominator. Okay, so what you want in fractions is to have the same denominator. So you're bang on, Faye, that is easier following that process. Okay, but that process isn't kiss smile, so that's why I'm reluctant to confuse you. Okay, now again, that will work further. Okay, and it's just the same process, so it's going to be the same final answer.
The other process, Daniel, is multiply the denominators together if you needed to.
That's what we did. That was that. So that's a kiss smile. So when you do kiss smile, you need to do that cross multiplication as well. Okay, so you're effectively doing the same thing. Okay, but we call it kiss smile because it's a nice wee thing to remember. Okay, but essentially you're doing the same thing. So if I have that line, 47 divided by 6 minus 10 over 3. Okay. I'm multiplying that whole thing by 3, and I'm multiplying that whole thing by 6. So I'm multiplying the top and the bottom by 3. If you think about it, okay, give me, what was that? 141. And then because of the same denominator, I can write it like that. Okay, so you don't have to multiply both, essentially, in this case. Okay. Okay. Write that down, put it to one side. When you've got an opportunity, watch this video again, okay, and try and make sense of that. That will be taught some ways in other resources, so I don't know what BBC Bitesize does, and I don't know what other resources do, okay, but it's actually a good one to know, just in case you see that come up, okay. So you only have to effectively multiply one of them to make it, okay. Now this will come up again, so we'll do another example.
Sorry, I missed the wee start bit of this. What's this called that we're doing?
Mixed numbers.
Okie doke. Thank you. I'll go back and watch this wee bit of the lecture.
No problem at all. No problem. Okay, so example 2. Okay. We do 4.5 minus 1 4/5. Okay, same process we want to start with. There's 4 wholes, so it's 4 times 2 plus that 1 over 2 minus 1 times 5. Okay, plus that 4 over 5. Okay. That gives us 8 plus 1 over 2 minus 9. Nope. Yeah, just do it. 9 over 5. Okay, so 9 over 2 minus 9 over 5. Okay, perfect. So in this case, the denominators, it's not easy. We can't double it or half it, okay? So we need, or it makes sense to do that kiss smile. Okay, so we'll follow that kiss smile process. Okay, we're multiplying across. So that's 45 minus 18 all over 10. Okay, 45 minus 18 is 27 over 10. In this case, 27 over 10 doesn't simplify any further. Okay, so if 27 came up, I'd look for some things dividing by 3. Okay, so 3 goes into 27, but it doesn't go into 10, so that can't be it. Okay, nothing else really goes into 27. Okay, 10 certainly doesn't, so we can't simplify it that way. Okay, so 27 over 10 doesn't actually simplify further any down. Don't know if that sentence made sense. Okay, but we want to take it away from that top heavy. Okay, so we want to remove that top heavy. Okay, so again, we just go through the 10 times table. So we go through the times table of the bottom number. Okay, denominator. So it goes 10, 20, 30. Okay, and that means we've passed 27. So 27 goes in there. Okay, so there's 2 wholes, which takes us to 20, and then we've left over with 7. Okay, so there's 2 whole 10s, and then our remainder is 7. Okay, it's not very well written out. Okay. Remember, just do that wee bit on the side. Okay, you're not going to lose any marks. Just make sure it's completely out of the way. Okay, and just do that in your head. Okay, some you'll see in your head. I mean, 27, you can see that there's 2 10s in 27, you're going to be left with 7. Okay, it's a nice easy one. If it's not so easy, just do it in the side and just work through that. Okay. Example 3, 7, oh, sorry. Plus this time, 1 1/3. So there's 7 holes, so 7 times 5 plus your 4. Seven 5 is 35, plus 4 is 39. 3 times 3 is 9, plus 1 is 10. Okay, again, best way to do this is get a smile. Okay, that first multiplication is not the easiest. Okay, but there's no real easy way to simplify it. Okay, so taking that first multiplication to one side. Okay, do it in the column method. So it's 3 times 9. 3 times 9 is 27. So 7 with 2 carried over. 3 times 3 is 9. Plus that 2 you're left with. It's going to be 11. Okay, we're left with 117. Okay. Second multiplication. Oh. Second multiplication is a wee bit simpler. Okay, thankfully. It's just 10 times 5, so that's 50. And then the bottom is over 15. Okay, so that's 167 over 15. Why have I got that wrong?
You just go back to the top for me, please.
That's wrong. I've got that second line wrong, guys.
Yep.
Yeah, sorry. That's 1 times 3.
Uh-huh.
Is that what you were thinking, Sandra?
Yeah, that's what I got, yeah.
Perfect. Superb. Alright, sorry guys. So I'd put 3 times 3 here. Okay, and it's 1 times 3. So just be aware of that. Just go back and rub that out. Okay, that means this number here will be 3 plus 1, which is 4. Okay, and that and there would be 20. So apologies, if you want to rub that out and just copy that again, I'll give you a wee second. Which makes that 147. 147. If you want to scribble out what you had and just copy that again. Sorry guys. Okay, so again, 147 divided by 15. Oh, sorry. My God, I can't add up. $137 divided by 15. Okay. What I'm looking at there, both of them don't divide by 10, though both of them don't divide by 5, and 3 doesn't go into 137. Okay, so there's nothing there, obviously, that I can divide both of those numbers to simplify it. Okay, so I'm just going to take the choice at this point just to go through my 15 times table, which sounds ridiculous, but just go through my 15 times table to simplify that fraction down. Okay, now you can write this down at the side, go over to the side of your exam paper, just 15 times 2 is 30, times 3 is 45, 60, 75, 90, 105, 120, 135.
8.
Oh. And then 150. Okay, so we're looking for 137. Where does that fit in? It's in here. Okay, so that's 1 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 whole 15s. Okay, and what we're left with 2. Okay, a remainder of 2. Okay, so we're going to get 9 wholes. Remainder 2 over 15. If anyone's got something different, let me know. Okay, I think I made about 4 mistakes in that. So, example 4. Okay. 3 5/8 plus 7 2/3. Okay, go through that process. 3 times 8, 24. So 3 times 8 plus 5. 7 times 3 plus 2. 3 times 8 is 24, plus 5 is 29. 21 plus 2 is 23. Okay. Horrible multiplications. Okay, but we'll quickly do them to one side. Okay. Oops. Okay, so 29 multiplied by 3. Okay, 3 9s are 27. 3 2s are 6. Plus that 2 you're left with, 87. Plus that 8 times 23. 8 times 3, 24. Left with 2 there. 2 times 8 is 16, plus that 2 is 18. Okay. Three times 8 down the bottom is 24. Okay, so you're sometimes left with some really, really horrible fractions. Okay. Not an easy add. Okay. 184 plus 87. Okay. Whatever way you do your adds. You can even take this to one side. Okay, so 184 plus 87. Okay, you can just add them together like that. So that's 11. 8 plus 8 is 16, so that'd be 17. And then your 1, so 271. Okay, left with something like this. Okay, so there's no obvious way to simplify that down. Okay, if anyone's got any questions about what I've been doing on this side, okay, don't see that multiplication. Don't know at what point that's taught. I think maybe in Nat 4. Okay, so have a wee look back about long multiplication and adding just in the column. Okay, but if you get a silly fraction like this, that's a good skill to have under your belt. Okay, that long multiplication. Okay, so we'll get something silly like this. So 271 divided by 24. There's no obvious way I can see of simplifying that down. Okay, so I want to see how many 24s go into 271. Now I could go through my 24 times table and write down the side every single 24, so 24, 48, all the way down until I pass 271. Or if I look at that number, the most obvious multiplication you can do is timesing something by 10. Okay, so if I times 24 by 10, it's at 240. Okay, I'm just adding a 0 to the end. That 271's above 240, so I can start there and then just go start at 240, and I know that's so. So I know 24 times 10, 240. Okay, so times 11 would be another 24, which is 264. 12 would be another 24 on top of that, which would be 288. Okay, so instead of writing out 24, 48, blah, 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 I just go to 24 times 10 and then add 24, add 24. Okay, it's just a wee time saver if that comes up, if that something like that comes up. So 271's in there. I know we've got 11 holes. Okay, so there's 11 whole 24 pieces. Okay, 11 holes takes us to 264. What are we left with is a remainder. We're left with 7. Okay, so we've got 11 remainder 7. Don't know where I went there. So we've got 7 over 24. Okay, that's as tough as they come. Okay, if that came up in a non-calculator, I'd be pretty miffed. All right, I'd be like, but follow the process, take your time, step by step. How do we multiply that out? Have a wee look back just to make sure you're comfortable doing things like that. Adding things together in the column method. Column method's probably easiest. Okay, you can do that in your head if you're feeling comfortable, but it's easy to make mistakes. Okay, if you're not sure what I'm talking about, look back and try and figure that one out. Okay. 11, 7, 24. Okay, that's been another hour, guys, so let's have another 10 minutes. Okay, and then we'll finish off mixed numbers. Okay, I just want a couple more things I want to do with fixed numbers. Okay, and then we'll need to leave percentages. Okay, and then we'll talk about Thursday. So let's have another 10 minutes. So let's take until 20 past actually. Let's just take until 20 past, guys. Let's go for it. Okay, so last wee bit I want to cover on multiplying, or sorry, on mixed numbers, sort of multiplication of it. Okay, now just like multiplication of fractions, it's actually a lot nicer, a lot smoother of a process. All right, it's just the top, multiplying the top numbers and multiplying the bottom numbers together. So we don't have to do that cross multiplication, then multiply the bottom or simplify anything. Okay, so hopefully just follow through a couple of examples of this. So we'll do a couple of multiplication ones. We'll do a division one and then we'll call it a night. Okay, and then we'll talk about when we want to do percentages. Okay, so multiplication of mixed numbers. Okay. Good timing. Good timing, Sandra.
Sorry.
No problem. Okay, so we're just going to carry out multiplication of mixed numbers. So in regards to the question you get in an exam, would be the same question. Simply be express as a single fraction in its simplest form. Okay, so that's your exam question. That's it. Doesn't give you any more information, doesn't, no more or no less. There's no reason to question it. All right, so example 1, 3 1/5 multiplied by 2 2/3. Okay, same process. So we want to create that top heavy fraction. There's 3 holes, so there's 3 full lots of 5. Okay, so just want to represent that. 3 times 5 plus that extra 1. Okay, there's 2 whole lots of 3, so it's just 2 times 3 plus that extra 2. Okay, so we're starting with, what's that, 15, 16 over 5 multiplied by 6, so 8 over 3. Okay, there's no way of simplifying them down or making it an easier multiplication. Okay, it's just process you work through, it will just be the 16 times 8. Okay, so remember, multiplication is just straight multiply the top, multiply the bottom. Okay, it's the easiest type of fraction question you can get. Okay, it's the nicest one. Okay, so if we are doing 16 times 8, remember you can just do it out to the side. You don't need to try and figure it out in your head and try and make it all in order. 16 times 8, 8 times 6, 48. Okay, so we've got 8, 4 left over. 8 times 1, okay, is your 8 plus 4 is 12. Okay, so we've got 128. And we've got 15 down the bottom. Okay. Similarly, it's not a particularly nice one. 15 into 128. We know 10 times 15 is 150. Okay, that's the easiest multiplication we can do with any. If you're comfortable, you can do 15 times 10 equals 150, and then actually work backwards. So you could do 14 times 10, oh, sorry. Why would you do 14? 15 times 9, okay, and then you take 15 off that, so it'd be 135, and then times 8 would be 120, okay, and then you've sort of located it. So either have start at 1 times 15 or start at 15 times 10. Okay, that's your 2 sort of milestones, okay, that you can sort of have, so everyone, you know, quite comfortable with that times 10. So we're in there. So we've got 8 holes, 8 whole 15s. Again, then we've got a remainder of 8. Okay, so we've got 8, 8, 15. So multiplication is lovely. Okay. Let's have a wee look at what could we do. Let's do this example because a few things are going on. So we do 5 3/4 times 3 5/6. Okay. 5 3/4, so there's 5 whole 4s, so there's 5 times 4 on the top, plus your 3 over 4 times 3 times 6, plus 5 over 6. So you've got 20 plus 3, 23, 18 plus 5, which is also 23 over 6. Okay, again, there's no easy way to simplify them down to give us better numbers. Okay, nothing really goes into 23 and 4, nothing goes into 23 and 6, so we can't really tidy them up any. Okay, so we're just going to have to go straight for those multiplications. Okay, so how do we do 23 times 23? The way I would do it is break 23 up, okay, into a 10, a 10 and a 3. Okay, so break it up. So you have one of the 23s. Okay, we can break that up into 23 times 10 plus 23 times 10 plus 23 times 3, which is a hell of a lot more digestible. Okay, so 23 times 30. 3 times 23 is 69. Okay, 460 plus 69, 529. Just double checking my calculator so I'm not telling you lies. Okay, but if you got that in a non-calculator, 23 times 23 is a hell of a multiplication. But remember, the rules of multiplication means we can break one of them down. Alright? So, a lot easier to digest. 23 times 23 is 529. Okay, and the bottom's 4 times 6, which is 24. Okay, now we've got a hell of a big number and a hell of a small number. What I'd usually look for is, can we divide them both by 2 and simplify that way? No. They both not divide by 10? No. Okay, so there's nothing really jumping out of me how to simplify that. Okay, so again, let's think about this sensibly. So we know that we can do 24 times 10 and it would give us 240. Okay. If we had another 10 of them, we would just have double. So if we had 24 times 20, we'd have 480. Okay. So if we had 480, we're getting closer to that figure and we just start adding on 24s. Okay, so that's not immediately apparent, but if you go to 24 times 10 and get 240, if you double that, okay, i.e. multiply it by 20, you're going to get double that figure. Okay, so it's another wee maybe trick that might come in handy in the non-calculator. Okay, now there'll be nothing more complicated than that. Okay, so we've got 24 times 20, which is 480, times 21 would be 504, times 22 would be 528, my god, times 23 would be 548. So wait, that's 8. Okay, so that wouldn't be 40, that would be 50. Okay, so that means our whole number is in here. So we've got 22 whole chunks. "22 whole chunks takes us to the number 528. So we've got a remainder of 1. Okay. So there's a few things in there, a few tricks to pick up on in regards to big multiplications and breaking them down, but also if we see a really top heavy fraction, okay, multiply the denominator by 10 first, see where that takes you, see if you can add on, and if not, multiply it by 20, and that's just double your multiple with 10, okay, that jump is just double. Okay, so just think about it sensibly, okay, and think about the rules of multiplication and what we can do with that. Okay, so a hell of a big number. You'd probably see that in the exam and you go, I've not got time for this. Alright, I wouldn't blame you. Alright. If you got to this stage, say that was worth 3 marks, okay. 1 mark for breaking it up and putting it in its top heavy fraction, 1 mark for getting the first full multiplication, then 1 mark for putting it back in. All right, so you'd get 2 marks even if you got to this point and you couldn't simplify it down anymore. All right, so just keep adding that step. Okay, and if it need be, if you run out of time, if you can't think, clear your head, go on to the next question. Just remember to come back, fold down the page. Okay, that's a good one. If you want to come back to a question, just fold down the corner of that page. Okay, just a wee reminder. I know that can be simplified, so I'll come back to it. Okay, I'd be aghast if you got something this tough in a non-calculator. Okay, but there's no reason why not. All right, that's what I need to tell you. So there's no reason why not. Right, last thing tonight is just dividing. Okay, so if you get divide, so an example, 2 examples of division, and then we're calling it a night. So let's go through it. So 2, 3, 8, so 3 8s divided by 5/16. Okay, so there's no number in front of that 5/16, so that's all that is. Okay, so we don't need to question it or go for it. Okay, so that first one we make top heavy. Okay, and then I'll just keep it as divide right now, and then I'll tidy that up. So we've got 16 plus 3, which is 19 over 8, divided by 5/16. Okay, now the rules for division is we flip that second term and then change the sign in the middle. So we've 19 over 8 multiplied by 16 over 5. Okay, so there's a way to simplify this down, but I'll go through the process again of multiplying it out in the long form. Okay, and then I'll show you the alternative method if you want to look at it. Okay, but it's not the worst thing in the world to know the long form. Okay, so 19 times 16. Okay, again we can break that down to 19 times 10 plus 19 times 6, which is not a particularly pleasant sum to do, but it's a lot more digestible than 19 times 16. Okay, so we've got 190. Okay, plus 19 times 6, which let's just do it at one side. Okay, 9 times 6 is 54. 6 and 11. Okay. So we've got 304. Yeah. It's a hell of a big sum. And 5 times 8, which is 40. Okay. Ways to simplify that down. I would say divide it by 2, so they're both even numbers, so we can divide that by 2, and that just makes it a wee bit more digestible. So that would be, behave yourself. The internet's been playing up a wee bit, so 304 divided by 2 is 152 and 20. Okay. Simplified it down a wee bit. Both even numbers again, so that simplifies down even further. Divide that by 2, divide that by 2. Okay. 152 would be 76 over 10. Okay. Again, you can simplify that. Okay, we're getting into a lot better numbers here. Okay, so half of 76 is 35. Oops. 38 over 5. Okay, and now we're at a point where we can't go any further. Okay, so we've taken what is quite a horrible fraction, we've simplified that down. Okay, so if they're both even, just go straight for dividing them both by 2. That simplifies it down, Okay, that's my go-to. Okay, if there's nothing more obvious there, just do that. Okay, then we can look at, right, 5, no, you can just write it out if you want, 5, 10, 15, 20, 25, 40, so we're in here, so 5 times 7 takes us to 35, remainder 3 over 5. Okay, there is an alternative method. I'm reluctant to show you, but some of you might have been taught this, and just as a wee reminder, okay, if you're comfortable with doing that one above, that's fine. Okay, alternative method. Okay. Allows you to simplify it at an earlier stage. So we've got 19 over 8 multiplied by 16 over 5. Okay, and this only works for multiplications. Okay, if that sort of cross multiple can be simplified, okay, so 2 8s go into 16. That means I can just put a 2 in that place of the 16. So I can effectively cancel out that 8 and cut that down to 2. Okay, so I'll just do that again. I can cancel out that 8 and I can put a 2 in that place of that 16. Okay, so that will leave me with 19 over 1, okay, which is just 19, multiplied by 2 over 5, which will just give me 38 over 5, which is a hell of a lot quicker than going through that long multiplication process. Okay, which will give me my 7, 3 over 5. Okay, so noticing we can do that simplification process. Okay, but that only works as a multiple if the number that's diagonal can be simplified by it. Okay, it's probably easier to do than it is to explain. Okay, so look out for that method. Again, it's something to look out for. Okay, now that doesn't work with add and subtract. Okay, just with multiples. Okay, so remember with add and subtract, what we're looking for is the same denominator. But it's a wee alternative method, which is a hell of a lot easier than doing that long multiplication. Again, knowing how to do that long multiplication is not the worst thing in the world, but it does take more time than that nice easy simplification. Okay, but if you don't see it, it's not the end of the world. Don't know why that one's there, but we'll just do it anyway, just so we've got another example. So another example, and this will be the last one of the night, just so you've got it before. Terrible division sign, but 4 and 3 quarters divided by 6 and 2/3. Okay, 16 plus 3 is 19 over 4. I'm getting lazy now. 18, 20 over 3. Okay. 19 over 4, multiple. Okay, so there's no easy way of simplifying that down, breaking that down. Okay, remember we can only do that technique, that alternative method, if one of these crosses simplifies down a wee bit. Okay, neither of which do. So just a case of going through it, and it's 57/80, and it's a rubbish example because that doesn't simplify. Okay, it's just another one to have there for reference. Okay, so any questions on that? Take a wee bit to time to digest that. Okay, and that in scientific notation. Now, we never got to percentages, but I sort of. Okay, so I never got to percentages, but I sort of would be keen getting that done this week, just so we stay on track. So I might change the plan for Thursday. Just so we stay on top of it. Oh, I'll stop recording.